Hello, my name is Cecily Holland, and this is my final project for CPSC 5530, Data Visualization and Exploration. This is the Leaky pipeline. It's a story about women in tech, where they enter, where they leave, and why we're losing the ability to even measure what's happening. I want to start with a number. In 1984, women earned 37% of the bachelor's degrees, the computer science bachelor's degrees in the United States. Today, that number is 24%. We haven't been building from a low baseline. We have been recovering from a regression in the field. And let's look at the data. This is the IPEDS dataset, the federal government's comprehensive database of degree completions at over 6,000 colleges and universities. I pulled 6 years of data from 2010 to 2024, filtered out just computing and engineering fields. And what you're looking at is women's share of degrees across different computing tracks. And a few things jump out immediately. Computer science, selected here, went from 12.8% in 2010 to 21.6% in 2024. That's only 8.8 percentage point increase over 14 years. That's less than half a point per year. And at that rate, we won't reach gender parity until roughly 2090 in this field. If we switch to information and data science, we sit at just over 30.7% women in 2024, with 6.6 points of improvement over the same time window. The same period, meaningfully higher representation. Fields that feel more interdisciplinary and applied are consistently attracting more women than core computer science. Where if we look at cybersecurity, it's nearly flat. 19.4 in 2010 compared with 19.3 in 2024. One of the fastest growing tech fields, projected to grow 32% this decade. And women's representation has essentially gone nowhere. If we look at computer engineering compared with electrical engineering, computer engineering sits at just 15.6% women in 2024, where electrical engineering, also low, also barely moving. These hardware adjacent fields have the most stubborn representation gaps of any tracks in the data. If we switch to doctorate degrees for computer science, you can see that the doctorate level is lower than the master's level and has been flat for almost over a decade. That suggests that women are advancing through master's programs, but hitting real barriers to academic and research careers. The education pipeline is improving slowly, but the gains are uneven, and none of it translates cleanly into the workforce, which is Act 2. The cliff. This is where the story gets a little bit more uncomfortable. This visualization uses Bureau of Labor Statistics current population survey data, 10 consecutive years from 2015 to 2024, and it tracks women's employment across tech occupations by bracket. So here you can see some of the statistics and the insights, but let's explore the chart together. Looking at software developers, we start in 2015, employment in thousands and age brackets on the bottom. And you can see that the peak for this type of employment is the 25 to 34 age bracket, and it drops significantly from there to the 35 to 44 age bracket. In 2024, it dropped by 24%, and they keep dropping by 55 to 64. The numbers are a fraction of what they were at peak. Watch what happens when I animate this across the years. The cliff doesn't go away. It persists from 2015 all the way through 2024. Every single year, the same shape. The drop is structural, not a fluke. Now, if we compare with computer systems analysts, when you can compare multiple of these tech degree paths on both sides, you can see that this field which is actually approaching parity at 43% women in 2024. Even here, you can see the cliff pattern. Women peak in younger brackets and decline in the older ones. The narrative in popular coverage tends to blame this on motherhood and work-life balance, but the research is more nuanced. Hostile work cultures, lack of advancement into senior roles, and what researchers call bro culture that women find increasingly intolerable over time. The data can't tell us the cause right now, but it consistently tells us that whatever is happening, it's clear, consistent, and persistent across every occupation that we tracked. Now let's look at the intersectional view. Act 3 asks a harder question. Does the cliff affect all women equally? The visualization uses NSF National Survey of College Graduates microdata, public use files that I filtered to computer and mathematical scientists, with survey weights applied for population estimates. I'm comparing 2019, pre-COVID, to 2023. Here's the heat map. Each cell here is a race ethnicity group, crossed with an age bracket. That color intensity shows the women's share of that group in computing. And the gray cells aren't blank spaces. They're suppressed cells where the sample size was under 20 respondents. That suppression in itself is a data point. It means the pipeline is so leaky for certain groups that the federal government can't produce statistically reliable estimates. There simply aren't enough women of certain races at certain career stages in computing to count. If we look at the change from 2019 to 2023, you can see COVID affected each group differently. Some improved, some declined. Some cells that had data in 2019 are now suppressed. The key takeaway here is that women in tech is not a monolithic group. A white woman in tech and a black woman in tech face different structural barriers, different pipeline pressures, and different rates of attrition. Aggregate statistics flatten that complexity in ways that can actually mislead policy. Looking at the data cliff now, this is where the story ends, with a twist. Just as we developed tools to measure progress, the data started disappearing. These are the big tech diversity reports. Voluntary annual disclosures that companies began publishing around 2014, after pressure from advocates and journalists. I compiled this dataset manually from company PDFs since no single structured source existed, and these solid lines show reported data. Watch what happens at 2024 to 2025. Google, gone. Microsoft, gone. Meta stopped reporting in 2023. 3 of the largest 5 tech employers in the world stopped publishing diversity data. If we look at the overall workforce view, this is where it gets interesting as well. The overall numbers look considerably better than the technical role numbers. Google's overall workforce was 33% women in 2024, where Apple sits closer to 35%. These numbers are notably higher than the 25 to 27% you see in technical roles. That gap between overall workforce and technical roles is itself a story. It means women are present in these companies, in HR, marketing, operations, legal, but underrepresented specifically in the engineering and product roles that carry the most power, compensation, and influence. Diversity at company level masks concentration at the role level. We look back at technical roles. Watch what happens when I enable projections. These dotted lines show where the trend lines would have gone if reporting had continued at the same rate of improvement. Google and Microsoft were both tracking towards roughly 30% women in technical roles by 2027. We'll simply never know if they actually got there. And if we look at some key events that happened over this timeline, we can see that the reporting cessation tracks directly with the political shift following the 2024 election and corporate backlash against DEI initiatives. The irony is that the data was actually showing that these efforts were working. slowly but measurably, and roughly 1 percentage point per year of improvement in technical roles. And the companies stopped measuring right when accountability mattered most. Without this data, researchers can't track progress, journalists can't report on it, and advocates can't hold companies accountable. The data cliff may end up being as consequential as the career cliff for women's long-term representation in tech. So that's the Leaky pipeline. 4 acts, 4 datasets, and a coherent story. Women are slowly entering computing education, but progress is glacial and uneven. Those who enter the workforce disproportionately leave in their mid-30s, and that pattern has not meaningfully improved in a decade. The cliff affects different groups of women in different ways that aggregate numbers hide. And now the infrastructure we would need to measure any of this going forward is fragmenting. All four visualizations are interactive. You can download the underlying CSVs directly from the site, explore different occupations and tracks, and toggle between views. The full report, pre-processing scripts, and data documentation are available in the GitHub repository. Thank you.